Now we're going to look at equations that not only do you have to simplify sometimes on one side of the equation, you also have variables on each side, which really isn't a big deal because we can still add or subtract the same thing from both sides, and we can add and subtract variables from both sides, and that's no problem at all. So what we're going to do, the first one, there is nothing we can simplify on either side. 2x plus 5 can't be simplified anymore. X minus 2 can't be simplified anymore. So what we're going to do now is we're going to work between the sides, and what we do to one side of the equation, we need to do the other. This one works out very nicely. We want all the x's on one side of the equation. To do that, all we have to do is add or subtract terms from both sides. Many people like to have their variables on the left side of the equation, and then some other folks would want to make sure they have positive values for x. Really, it doesn't matter either way, and sometimes they both work out. In this case here, I'm going to go ahead and subtract x from both sides of the equation. The reason I do this is because over on the right side, x minus x is 0. And so I chose to subtract x, so I would have no x's over there, which leaves me with just negative 2 on the right side. On the left side, I'm left with 2x minus x, which is x, and then I still have the plus 5. And now this is very simple to solve. We can go ahead and subtract 5 from both sides. And when we subtract 5 from both sides, we get negative 2 minus 5, which is negative 7. We know we can check these. So we're going to check. We're going to put negative 7 in for x to see if it's correct. 2 times negative 7 is negative 14 plus 5. Negative 7 minus 2 is negative 9. And when we figure out negative 14 plus 5, that's negative 9, and it does equal negative 9. So x equals negative 7 is the correct answer. Our second example, we see that we do have to use the distributive property first. So we're going to distribute the 3. That will give us 3x minus 12 is equal to, using the distributive property again, 4x minus 24. Again, we have variables on both sides of the equation, on both sides of the equal sign, so we're going to use adding or subtracting the same thing from both sides to get x's so they're just on one side. Because I like the variables on the left side, I'm going to go ahead and subtract 4x from both sides. On the left side, 3x minus 4x is negative x minus 12 equals, I chose to subtract 4x so these would become 0, and just left with negative 24. Finishing this off, we can add 12 to both sides, and we get negative x equals negative 12. And we have a negative x equals negative 12, so there's two ways to handle this, actually probably even more than that, but we can divide both sides by negative 1, because when we divide by a negative 1 it changes the sign. We also could have said, well, multiply by negative 1, but negative 12 divided by negative 1 is 12, and x is equal to 12. I'm going to go ahead and try to squeeze in just another way. I'm going to rewrite this blue part here. So after we distributed, we got 3x minus 12 equals 4x minus 24. And I said I like to have my variables on the left side, so I'm going to go ahead and subtract 4x. But now I like to have my variables to be positive. So what I can do here, since the 3x is smaller, I know that in the long run when I subtract 3x from both sides, I can think ahead and realize 4x minus 3x is just x. And so maybe I want to subtract 3x from both sides. Either way is fine. So if I continue working on the right, I have 4x minus 3x is the x minus 24. On the left side, these become 0 and I get negative 12. Now I can add 24 to both sides. Negative 12 plus 24, I get 12 equals x, which is the same as x equals 12. And so either way, whether it's this first way or the way I just did it, we still get x equals 12 as our answer. We'll do a couple more examples that kind of gain in complexity. Here's some steps for solving multi-step equations, so they're not just the straightforward ones. We have to do different things to them. So we'll simplify both sides by removing parentheses and combining like terms. So this could take a few steps, but that's what we want to do first. Now we can only simplify sides. So we have a left side and a right side. I'm going to go ahead and draw a line here just to show we're working with the left side and the right side. On the left, we have a 3x plus a 5x, which is 8x minus 4. On the right side, we can't add x and 2. They're not like terms, so we leave it as x plus 2. Now we're left with something that has variables on both sides. We'll go ahead and get the variables on one side. So I like to move the variable first, so I'm going to subtract x first from both sides, knowing that becomes 0 over here. And so we're just left with a 2 on the right side. On the left side, we're left with 7x minus 4. Now we know we can add 4 to both sides, leaving us with 7x is equal to 6. And then dividing both sides by 7, we get x equals 6/7. So our answer is x equals 6/7. Our next example, we notice that we have to distribute first. So we'll go ahead and distribute this 3 to both of these. We get 12x minus 15 plus 2 equals 12x plus 6. So I'm working on simplifying both sides, so I use the distributive property. Now I see that I have like terms here. So this is 12x, negative 15 plus 2 is negative 13, or minus 13, equals 12x plus 6. Now I want to get all my variables to one side, and so I think, okay, I want to get this 12x out of here, and some of you might realize there's going to be a problem here. We subtract 12x over here, that's 0, and so we get 6 on the right side. Over here, 12x minus 12x is also 0, and we get negative 13 on the left side. So we've come down to a little problem here. We have negative 13 equals 6, and we know that negative 13 does not equal 6. This is not true. And so if you ever get down to working through an equation and you get to something that was false, then there is no solution. Now what that means is there's no value or no number that I can put in for x that will make this true. It will never be true no matter what I choose for x. And so that happens if you get down to something that's false. Now, if I were you, I would go ahead through and check it and do it one more time just to make sure you didn't make any mistakes. But in this case, there is no solution. And that's what our next slide was about. No solution. An equation can have no solution if there is no value of the variable that makes the equation true. And that's what we just had. And the way that we can tell if we get no solution is we get a false equation. So when you work through it, you end up getting a false equation. That means there's no solution. Let's take a look at example 5. First thing we want to do is simplify each side by using the distributive property and adding like terms. So we can distribute that that negative, so we get negative x, a negative, distribute it here gives us a positive 4, equals, this is negative 2x plus 12, and then we have plus x out here. Adding like terms, we have 12 minus x is equal to, over here, like terms, we get negative 2x plus x is negative x plus 12. You might notice here this is the same. If you don't, you might go ahead further and say, well, I would add x to both sides. Adding x to the left side, you get 12. Over here, you get 12. Well, now we still didn't solve for x. We don't have an x equals, I should say. It doesn't say x equals 7 or x equals 9 or x equals 12. It says 12 equals 12. And 12 equals 12 is a true statement. If you get down to something that is a true statement, that means the solution to this is all real numbers. And that means any number, I could plug in any number in for x, and it would make that original equation true. So my answer to this is all real numbers, because I came down, the way that we can tell that is if we solve our equation and we come down to something that's always true. So in the last example, we came to something false, and we got no solution. This example, we came to something that was true, and so it's all real numbers is the answer. And so an identity is an equation that is true regardless of the value of the variable. So in that case, that would have been an identity because the solution was the set of real numbers. So we have, sometimes you have no solutions, sometimes you have all real numbers work, so infinite solutions. And then this last example here, solve 2 times x minus 3 plus 6 equals 3x plus 2 minus 2 minus x. It looks complicated, but what we're going to do is we're going to take it a step at a time, simplifying each side first. So we don't want to work between sides now, we just want to work on the left side of the equal sign, and then on the right side we're going to work separately. So we'll go ahead and distribute this, which gives 2x minus 6 plus 6 equals 3x plus 2. We're going to distribute this negative, which gives a negative 2 plus x. Still simplifying on the left side works out nicely. We have a 2x minus 6 plus 6, that's 0, so we have 2x on the left side. Over here we have 3x plus x is 4x, and again we have a 2 minus 2, which is 0. Now be careful with this. Some people are going to say, well, I have 2x equals 4x, and that's something that's false. It is not false. We can keep solving this. So don't jump to conclusions. If you get two numbers, like 12 is equal to 12, that would be, like our other example, that would be also all real numbers. And sometimes we got something that was false, like in this example down here, we got negative 13 equals 6. That's false, but this one is not necessarily false because we still have variables on both sides. So what we're going to do is get all variables to one side. So I'm going to subtract 4x from both sides. And when we subtract 4x from both sides, we get negative 2x is equal to 4x minus 4x is 0. And now you might start thinking, well, what times negative 2 equals 0? And we know it has to be 0, but we can keep solving. As we learned already, we can divide both sides by negative 2. And 0, and really anything for that matter, if we take 0 divided by negative 2, or 0 divided by anything is what I was trying to say, is 0. So x is equal to 0, which means if I plug 0 back into that equation, it would work out. And we can go ahead and check it. 2 times 0 minus 3, so I'm taking my original, plugging in my answer, plus 6 equals 3 times x, which was 0, plus 2 minus 2 minus x, which was 0. Here we have 0 minus 3 is negative 3, plus 6. This is 0. Then we have 2 minus, and 2 minus 0 is 2. That's negative 6 plus 6 is 0, and that is true. Negative 6 plus 6 is 0, so 0 equals 0. Our solution is correct, so x is equal to 0.